Hi guys, this video follows on from a video on factorising quadratics. This is factorising harder quadratics. Let's just get a grip first of all on what I mean by that. A quadratic is an amount of x squared terms, an amount of x terms, and a constant, a number term at the end. Something like 4x squared plus 7x plus 3. That would be a quadratic equation. Okay, easier quadratics to factorise will have a coefficient of x squared of 1. So it'll be x squared plus an amount of x's and a number. Harder quadratics will have a coefficient of x squared that isn't 1. 2x squared, 3x squared, 4x squared, 5x squared, probably the biggest one we'll have to deal with in GCSE Maths. Let's recap though easier quadratics to begin with, where the coefficient of x squared is 1. And let's start by asking the question then, what does team stand for? Have a think. And the answer is times for the end, add for the middle. But as we know, that add can also be subtract. So we're looking to create a sum with two numbers, which could be an addition or a subtraction. Okay. Let's have a look at a couple of examples. At any point, if you want to pause to do these yourself, by all means do, but I'll keep going through them. So in this one, if we see this is an easier quadratic, 1x squared, okay, all we need to do then is find two numbers that will times to make the end number 20, but we'll also add or subtract to make that middle number plus 9. We do that with a little table. I'm not going to do that here, okay, but we've set it up, our double brackets. So we've put the x at the start of each bracket, x times x, giving us our x squared. And just a quick thought, you could probably do this one in your head. Two numbers that will times to give 20 could be something like 1 times 20, 2 times 10, 4 times 5. And the one that will obviously add to make 9 would be 4 and 5. So plus 5 plus 4, or plus 4 plus 5. It doesn't matter which order we put them in. A second example, again, set up the same. X at the start of both brackets. Looking for pairs that multiply to give 18. 1 times 18, 2 times 9, 3 times 6. And the most obvious one that I can make minus 11 with is a 2 and a 9. But this time, it's not plus 11, it's minus 11. So both my numbers need to be negative. Minus 2, minus 9. That will give me the minus 11. Quick check, if they are both negative, minus 2 and minus 9, to give that minus 11. If I then multiply them, minus 2 times minus 9, that would give me the plus 18 that I need. So both work, the times to make the end and the add to make the middle. A third one for you to try. As always, pause if you want to overgo yourself, but here's the answer. Now a fourth, what I will pick up on here is that you might ask, well, what is the middle number in this case? It's minus x. Well, there's kind of a hidden 1 there, so the middle number is minus 1. So two numbers that times to give minus 20, or to begin with, just times to give 20, but we'll add or take away to give minus 1. I'd be thinking probably of 4 and 5, okay? 4 times 5 is 20. 4 take away 5 is minus 1. And also with the 4 being positive and the 5 being negative, 4 minus 5, when they multiply, they'll also give me the minus 20 that I need. Okay. Two more to go. Have a look at this one. Have a go yourself. And here comes the answer. And a final one. And here's the answer. Okay, so now we need to look at some of these harder quadratics with a number before the x squared. I've managed to find there are lots of methods, and depending on your tutor, your teacher, you could get hit with any one of the methods here, which is a bit awkward for pupils, I know. But my kind of preferred method is the one that is most similar to team. There are probably 3 slight differences that we've got to take into account, okay? Difference number 1, when we set up our brackets, instead of putting x at the start of both brackets, we put whatever the coefficient of the x squared is with an x. So in this case, because it's 2x squared, we put 2x at the start of both brackets, okay? As it says in the green, set up the double brackets using the coefficient of x squared. The next slight difference is, whereas team, the TE is times to make the end, we slightly tweak the end. The end number here is plus 3, but before we call that the end number, we have to times it by the coefficient of x squared, the number before x squared, in this case 2. So we do 2 times 3. So we have to think of our end number as 6, not 3. So a slight difference again. So numbers that will times to give 6. We could do 1 times 6 or 2 times 3. Now we've got our pair list. We're looking for the numbers that will add or take away to make the middle number, which in this case is plus 5. This is not a good example because both those pairs will make plus 5, so it's a little bit more awkward, and I can see why this possibly isn't the best example to start with. However, what we've got to do if that is the case is look at both pairs individually. 1 and 6, to make plus 5, I'd have to do 6 take away 1. In other words, the 6 is positive, the 1 is negative, 6 take away 1. But if I times those, 6 times minus 1, I get minus 6, which is not what I want here. I want plus 6, okay? If the second example, though, 2 and 3, they will add to make plus 5. 2 add 3 make plus 5, and they are both positive, plus 2 plus 3. If you multiply those, you get plus 6, which is what I want. So that is the correct pair to make here. This little yellow note is kind of explaining that. As this number is saying here, this 6 is positive, we need the pair to be both positive numbers, so they multiply to make the positive 6, or both negative numbers, so they multiply to make the positive 6. So we've gone with the 2 and the 3. Okay, we do exactly like we did when we did this for easier quadratics. We put those numbers now, the plus 2 and plus 3, into the brackets. But whereas normally that would be the end of the question, the third change, okay, is that we have to look at both brackets, and if there is a common factor, a number that goes into both the numbers in the brackets, we must divide by it. So bracket number 1, 2x plus 2. 2 goes into both those things, so we divide that bracket by 2. The second bracket, 2x plus 3, there is nothing that goes into 2 which also goes into 3 other than 1. No point in dividing by 1. Okay, so we leave that as is, giving me the final answer. Half that first bracket is 1x plus 1. Okay, a second example. First difference, double brackets, both with 3x this time. That is the coefficient of x squared, so 3x, okay? Times to make the end, but the end is going to slightly change. It's not minus 8 anymore. Because there's a number before the x squared, I have to times the minus 8 by 3. So I'm actually looking for an end number of minus 24. Here are my list of numbers that will make 24. I know it's minus, but we'll come back to that. 1 and 24 will times to make 24. So will 2 times 12, 3 times 8, and 4 times 6. This is a little bit easier, I think, than the first one. We now have to add or take away one of these pairs to make minus 2. And a quick look down that list, there's only one option here that will do that, the 4 and the 6. Is it 6 take away 4? No, that's 2. But 4 take away 6 is minus 2. So the numbers that I need are 4 take away 6. Now if we have a look at the yellow box, that also works here, because as the 4 is positive and the 6 is negative, 4 take away 6, if we multiply those together, we will get the minus 24 that we wanted from the times part. So into the brackets they go, plus 4 minus 6. But not quite the end. We now look at our brackets and think, is there something we can divide either bracket by to kind of simplify that bracket, as it were? Well, nothing will go into 3 that will also go into 4, but with the second bracket, 3x minus 6, I can divide both those numbers by 3, giving me x minus 2 as my second bracket. Two more examples for you, just a lot quicker. We'll try and get through these, okay? Again, set up your double brackets. As it's 2x squared, we're going to put 2x at the start of each bracket to begin with. The end number is minus 21, but that needs changing because there's a coefficient of x squared, so we've got to do 2 times minus 21. So effectively, we're thinking of our end number as minus 42 in this case. What factor pairs will multiply to give 42. 1 times 42, 2 times 21, 3 times 14, or 6 times 7. We'll worry about the fact it's minus 42 in a second. Looking at those pairs, how can I make, and with an add or subtract them, how can I make the middle number? The middle number is plus 1, it's plus 1x. Well, there's only one pair there that I'm going to get close to plus 1 with, and that's the 6 and 7. And to make plus 1, it will be 7 take away 6. As a quick check, plus 7 minus 6. That's the sum we're contemplating here. If we multiplied those, or plus 7 minus 6, we would get minus 42, so that kind of works as well, and that's always worth checking. Okay, that's what these little notes say. As this is negative, we need the pair to be plus and a minus, or a minus and a plus, which is exactly what plus 7 and minus 6 is. We can put those into the brackets, plus 7 minus 6, and in this case, it's the second bracket that can be reduced. I'm using the word simplified, not quite the right term, but basically 2 goes into 2x and 2 goes into 6, so we can divide that second bracket by 2, giving us the final answer 2x plus 7, and the second bracket becomes x minus 3. And a final example. The coefficient of x squared this time is 5, so our brackets start with 5x. 5 times minus 3 gives me my new end number, which is going to be minus 15. So I'm looking for factor pairs that will make 15. 1 times 15, 3 times 5, and that is it. Which one of those factor pairs will allow me to make the middle number, the coefficient of x, which is plus 2? Well, I'm certainly not going to do it with 1 and 15, but with 3 and 5 I can. 3 take away 5 would be minus 2, 3 add 5 would be 8, but 5 take away 3 gives me the plus 2 that I want. Okay, so plus 5 minus 3, and yet again it works because plus 5 times minus 3, the plus times the minus, will give me the minus 15 that I am looking for. Let's put those numbers in, plus 5 minus 3, and this time the second bracket can't be reduced, but the first bracket we can reduce or simplify those numbers by dividing them both by 5, giving me x plus 1, and the second bracket hasn't changed, 5x minus 3. Now there's a couple of questions here, so by all means pause the video and have a go. If you're doing this on a class notebook page for me, I will be using these examples in it, so you can stop the video now and have a go at these beneath this video. For anyone else, have a go, pause the video, and I'll give you the answers shortly. And the answers are I hope this video has helped. I understand, as I said at the start, the method is quite constant for most math teachers on how to do easier quadratics, but for these harder quadratics, there are a couple of different ways to do this. I like this method the most because it is most like the method I use for easier quadratics. But if you are shown other ways and you prefer them, by all means use them and come back and just check that you get the same answers doing it the way that you do it. Hope this video has helped, and speak to you soon.